Okay, here goes my 4 millionth attempt at making a video of this power hammer. I respect to these guys that make videos all day long, because this, wow, massive pain in the you-know-what. What we got here is a 26-pound, 2 horsepower power hammer. I'm just going to run through the sequence here. The very last thing we're going to do is fire it up, show you it working. I'm pretty sure what's happening to me is once I turn the power on and fire this power hammer, the level of noise coming out of it is shutting the sound down. So I'm going to try this with that being the very last thing I do. So let's take a quick look here. What we got is a 5/8 drive shaft sitting in 3 pillow blocks. We got 2 up here and 1 on the eccentric / actuator. 5/8 is more than adequate. I see guys building these with 1 inch and 1.5 inch shafts. Just absolutely ridiculous. That's a 10-inch pulley. We'll get back to that. The eccentric is a piece of 3/8 steel, 7.5 inches in diameter. The little holes in the middle are where I put it on my lathe, faced it on both sides, and turned it for true. I also drilled my 5/8 hole in the middle for that, welded that shaft both sides, then just ground this side off. Your pivot point right there is a grade 8 5/8 bolt, head cut off, welded all the way around on both sides. That makes that fairly stable. I use those little magnets to hold it in place while I got it on there and held it real true. 3 of them, not 2. Pillow block is mounted to a piece of quarter. This piece of angle started as 3x5. It's actually cut down to 1.5 by 3. Your actuator here is made out of 1.5 1/8-inch wall tube stock, and we have 1/2 inch bushes welded in here. All the bolts are 1/2 inch. This piece of steel here on these is 1 inch solid steel bar. Then we come down to 1/4, 1.5 tube stock, which makes this swing arm here. The pieces on the top of the hammerhead in here are 1 1/8 diameter, 1 inches across, with 5/8 holes in them. This is a piece of 1/2 inch by 1.5 inch flat bar, and these are just welded on true and drilled through. I actually did the drilling on those on my lathe. Our hammer is 2x2 steel bar stock. Its total length is 19 inches. The slider right here, the sleeve if you will, is 2.5 by 2.5 by 1/4 inch. This is a size commonly used to make receiver tubes for hitches, so it's readily available. The hammerhead right there is 4140. The risers on it are 3/4 by 1/4 inch steel plate. The reason it's put on that way is because the 4140 is tool steel. And when you're going to weld mild steel to tool steel, you should preheat that steel. I have a nailing oven up above, and what I do is preheat it to 500 degrees, weld it, let it cool naturally. I did not harden this 4140. In its annealed state, that 4140 is roughly 40 Rockwell, still way harder than mild steel. The flatter that's in there belongs on my treadle hammer. I haven't made the actual Hardy tools for this yet. My intention is to make a fuller, a butcher, and a flatter for it. When I make the flatter, it'll be 3x3, same as the hammerhead. What we're mounting right there, this anvil mast is actually 2x2 by 1/4 inch tube stock. The head on it is 3/4 inch 3x3 with a 1 inch Hardy hole. Moving around to the side, what we use here is just a conventional household light switch, about 99 cents a piece, steel box tacked in place. She comes down here to this device, which I've discussed nomenclature numerous times. This is actually called a motor base, guys. What most people call it's a power port. What that does is lets us unplug the motor. We can take the motor off of this thing by pulling that plug, pull this pin, take the pin out, motor comes off. Makes it workable. The 2-inch drive pulley on this motor is designed to take a 5/8 belt. Our belts are 1/2 inch. The reason we're using a 5/8 pulley there is it makes that slip action work better. We're driving a 6-inch pulley that drives a 1/2 inch by 2-inch pulley that's actually driving our main axle pulley. This 6-inch pulley steps our speed down from 3450 on the motor, which, by the way, that's a 2-horsepower V4 motor, 3,450 RPM, 1-year warranty, mind you. I paid $106.99 plus tax for it. Freight was free. In here are 2 pillow blocks that I made myself because I wasn't smart enough to realize I could buy a pair of these pillow blocks at Walmart.com for $16. I spent the better part of 3 hours making these. Anyway, off to the other side. This pulley drives this pulley, which is a 10-inch pulley. The 10-inch pulley, which is our main drive, actually gives us a speed at the actuator. I'm going to rough it out at around 400 RPM. That's what the math says. What I can tell you is that hammerhead at full speed ahead is hitting somewhere between 3 and 4 hits per second. That's at the fastest speed you can go. If a guy wanted to go faster than that, which I can't imagine why, reduce that 6-inch to a 5. And then instead of a 34-inch belt there, you would go to a 32, probably a 32. You have to do a little experimenting. They got pissed off at me at the auto parts store by the time I was done. I tried 4 different belts before I found the one I liked best. These are coasters. And these are on here because when this was floating free without these, and you were running the machine, the belt tended to bounce and flop around a lot. It still drove just fine, I didn't like it. What you have here is a 3/8 bushing and 3 washers. These washers on this side are tacked, which prevents this coasting, and then just tacked to the wall. On this side, we have our pedal and control system. We got a pin here that lets you pull a hairpin, pull the pin out, take this nut loose, and you can pull the pedal off. We got 1 spring supporting the motor, goes down through this bolt, makes this height adjustable. Note that slot right there that I used to get that bolt in and out of that 1-inch tube. That tube, if I'm not mistaken, was 26 long at the start. I made it so she would just clear the edge there. The reason I made this as adjustable is because different people have different sized feet. And just by spinning this nut up and down, you can raise and lower that pedal quite a bit. It doesn't look like it, but you have to remember that the difference, you come up 1/8 here, it's going to lower that pedal 1/2 inch. Okay, so that being said, you actuate it over here just by stepping on the pedal, and that moves the motor and tightens the belt and speeds the darn thing up. I can't fire this thing until we're done because I'm pretty sure the noise from the hammer shuts my sound off. These are some tooling I made for it. This is just a flatter. It could double as a fuller, but its main function, the main reason it's round on top, is so that if you were making a taper, you would go through your flatters and have steps on your taper as you got smaller and smaller. When you're done, you're going to have little steps in your taper. You take this and lay it on it, and that hammer doesn't know what part of that round stock it's hitting as it drives that down onto that piece you're tapering, and it will smooth those steps out. This is a smaller version of the same flatter. That one's 2 inches across. This one's 1.5 inches. This is a 1 1/8 fuller. Now, what I use this for is making hammerheads. I don't have any other use for it. That's the only time I ever use it. There's a regular conventional size 3/4 inch fuller. Then we have our butcher here, which gotta have a butcher. And then we have a manual flatter that lets you control what you're flattening from the top. My intention for the anvil is to make a fuller a butcher, and a 3x3 flatter. Those will all be 4140, unhardened. I'm going to walk up real quick, show you guys the option that's available to those of us that don't have the money or the space for a power hammer or the skills to build one. Because if you can't build the damn thing, my thinking is that hammer right there is probably worth $2,000. That's more money than my wife would let me spend. That I know. She put me on an allowance when I retired. She gives me $200 a month, and I burn that up the morning she gives it to me. So I have to build stuff and sell it to make money. This is a treadle hammer. I built this years ago. It's built on a Clay Spencer design. It's a very compact version of a Clay Spencer with all the extraneous stuff removed. This baby is running a 25-pound hammer. The hammer on this is a piece of tube stock. But what I did is just backfill it with molten lead. And then I made some slugs that I can add to it so I can bounce the weight on that hammer. When I start working 52-100, this hammer goes from 25 to 35. That's just a necessity. That stuff's really hard to work. Flasks for a melting furnace, gas melting furnace. 2 electric ones inside. Here's one of these hydraulic presses built out of a log splitter. These actually work, guys. Don't let anybody tell you they don't. That's for making long stuff hot. That's coal-fired right there. And that's a brine quench tank on the end there. Which reminds me, I better get that dumped out or it's going to rust its way through pretty quick. And then I'm not going to have a brine tank anymore. I'm pretty sure that we're going to lose the sound as soon as I hit this hammer, if I haven't already, because of the treadle hammer. I am literally speaking right into this mic. But I'm pretty sure sound's shutting down. Anybody has any questions after they watch this, PM me or email me. I'll get back to you. Once I hit this hammer, I'm pretty sure we're going to lose sound. So if I just go away and you don't hear from me anymore, you'll know what happened. You can make this move. As fast or as slow as you want, based on how hard you press the hammer, the pedal. In my mind, once the guys had this machine working for a while and used it for a while, they become very familiar with that. And then be able to control it fairly well. All right, guys, that's it for me. I'm out.